Okay, so back where I left off in the last video, I had just submitted the contains duplicate problem and got that one correct. So now let's go back to the list of questions, and I guess I can check off the first one is done. Perfect. So one down, 149 more to go. So I guess next is valid anagram. So let's open that one up. And okay, great. This is stayed Python. So let's see what we've got here. Valid anagram. Given two strings, s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So let's see what they mean by this. So if we're given S is the word anagram, and T is nagaram, which is anagram A-N-A-G-R-A-M. So these are the same, these two words are obviously different, but they're composed of the same letters, so this is true. Whereas if we look at rat versus car, rat has R, A, and T. Car has R and A, but it doesn't have a T. So these are not anagrams. So we have to check that T is an anagram of S, and we're rearranging the letters. Yeah, typically by using all the original letters exactly once. So that means if the words are different lengths, then we could probably instantly rule it out. Yeah, okay, great. So let me pull this question into an image and load it onto my notepad. Okay, great. So here's the problem statement again. And as I was talking through the problem there, I think I noted down a few important things. And that is, if the length of S does not equal the length of T, then we know that we can return false, that they are not anagrams, right? And that makes sense, because if we had rat and rats, there's no need to even check what the actual letters are, right? Because these are not anagrams of each other, simply because one is length 3 and one is length 4. So I think that gives a good thing to start with, that we want to check the lengths of each one, and if they're different, we can immediately return false. But then, if the lengths are equal, then we need to check that all of the letters in one string are equal to all of the letters in the other string. So I guess there's a couple of things that we could do that come to mind. And again, I haven't done this problem before, so I'm brainstorming here on the fly. We could sort first, then compare. And what I mean by that is, we could, for example, with the anagram and nagaram, if we sorted an anagram, that could end up being A. What I mean is put it in alphabetical order. So there's 3 A's, so it would be A, and then G, then M, N, R, I believe. And then if we sorted Anagram in the same way, it would give us the same thing. So that's one way we could do it, for sure. So this is, I'll call this option 1. But then there's something else that we could do, right? Which is we could go through the string. Say the string was ABCD. We could go through the string one letter at a time and count, basically, how many of each letter we've seen. So we could go through and say, we've seen A once, now we've seen B once, we've seen C once, we've seen D once, like that. And say there was another D or something at the end of here, then we could say that we've seen D twice. And then we could look at another word, let's say D, B, C, A, D, and then we would see that the counts match exactly, right? There's 2 Ds and then 1 B, 1 C, 1 A, which exactly matches what we wrote here. So I guess I could call this technique letter counts. And that would be option 2. We could probably do something even more clever, where we make an array, say, of length 26, and we just increment whichever spot in the array of the letter that we see, and then check that those are the same for each one. So we have a lot of options. I think if I were doing this in an interview, which I'm pretending this is, I guess I would go with letter counts, because I don't know the Python function off the top of my head that would sort these. Maybe I'll check that on Stack Overflow afterwards to see if I can find something. So let's go with the letter counts option and see where I can go with that. So I'll pull the code up. Right, so the first thing I mentioned is if the length of S does not equal the length of T, then we can return false right away. Sorry, I was just recalling if I have the right syntax there for not equals. I think that's correct. So yeah, if the lengths of the 2 strings are not equal, we can return false right away, because there's no way that they could be anagrams. So now we want to check if they have the same letters in each. And so I think I'm going to do that with a dictionary, because if I flip back down to my drawing here, if I want to go with option 2 and I want to count how many of the letters I see each time, then this part down here, where I am keeping track of all of the counts, I think the easiest way to do that might be with a dictionary. So let's go ahead and do that. So we'll say call it letter counts, and I'll set that equal to an empty dictionary. And then we need to iterate through, so I'm going to have to do one word at a time and build the dictionary for each. So letter counts S can be this one. And so we'll say for C for character, inside of S, we can say, I'll even do this, for a letter in S, just so it's a bit easier to read. What we can do is say, existing letter equals letter counts S, which is the dictionary. And then we can say letter actually, if I'm remembering my Python correctly, we can do this. What I'm trying to do is check if the letter already is in the dictionary, and if it is, increment it. So I think what I can actually do is just say if letter counts, I'm going to shorten this so it's easier to, nah, this is fine. If letter counts S letter, so basically what I'm saying is if the dictionary contains the key, whatever the letter is, because if it didn't, this would return none, and the if statement would not work. So if the letter is already in there, then we can say letter counts S of letter equals letter counts S of letter plus 1. So we've incremented the count. Else, meaning it's not in the dictionary already, we can say letter counts S equals 1, right? Because this needs a letter. Equals 1 because we're seeing it for the first time. So let me recap again what I just said here. So we go through each letter. So for example, in anagram, we would start with A. And we would say, does our dictionary contain the key A? It does not. So we would go down to this else statement and we would say, okay, let's add an entry to the dictionary that the key A is equal to 1 because we've seen A once. Great. So then we would go to N. The same thing would happen. We would create an entry for N, say that we've seen it once. Then when we get to the next A, we would ask, is the key for A in the dictionary already? And it is. So we would increment the count by 1. So now A would equal 2. And then we would go through the whole dictionary like this. Okay, great. So then we can do this same thing for the second string, which is T. So I'm just going to copy and paste the code to make this a bit quicker. Make sure I change all my variables properly. It can be a dangerous game to copy sometimes. But if I've done that correctly, then we do the same thing for T. And then here's the part where I'm not exactly sure how to compare the two dictionaries to see if they are equal. I'm wondering if I can just say if letter counts S equals letter counts T, return true, that they are they are anagrams. Otherwise, we return false. I'm going to put a question mark here because I'm not sure if this is right, because I basically need to do a deep equals, which I'm sure there's a way to do in Python, but I'm not remembering it off the top of my head. So let's run this on the test cases. Runtime error. Key error. So I think what this is telling me is I can't, oh, right, because this returns, and I mentioned this returns none if it evaluates. This doesn't return a Boolean. There's probably a Python function that could return if the key is there or not, but I think what I need to say is if this is not none, and then the same thing down here, like that. Let's see if that at least runs. I might need an is as well. As you can tell, it's been a while since I've done Python. Okay. Clearly I'm missing something. Maybe key error. Let's see. So it looks like I've been doing this completely wrong if you look at down here. What I really want to be doing is checking like that. So we really want to say if letter in letter counts s, like that. Yes, okay. And then same down here. If letter in letter counts t, like that. And semicolon. This is good fun because everyone here gets to watch me struggle, which is which is the point. I'm trying to learn. But look, okay, we're seeing accepted here. So anagram nagaram. True. Sorry, let's make this bigger. And case 2, those returned as false. So let's submit this and see if this works. Ah, nice. Oh wow. Oh, you're kidding. So I figured I did this one terribly compared to the first one because my solution felt rather long and clunky. But my runtime is way faster than most of the other solutions. I've beaten 75% of them. And my memory usage is better than 84% of solutions, which is shocking. I wonder if it's because instead of declaring an array of length 26 to handle all the letters, I've declared the smallest possible data structure for what I'm using, because I'm only adding letters to the dictionary that actually exist. But anyway, that's great. And I only had to look up one thing, so yeah, there's my solution again. And we can go back and check off the next one. Excellent. I will see you next time for the to-sum problem. Thanks so much for watching. Just to keep track of where we're at in the series, I've now finished 2 of the 150 problems, and I've queried Stack Overflow a total of 1 time.